Hello and welcome all on Unacademy JEE English, a channel launched by Unacademy where each and every topic of JEE will be covered in pure English. I am Rahul Kaushik and today I will take your lecture number 2 of mole calculation. And before that, I've already taken lecture number 1. In lecture number 1, we learned how to calculate mole. What is mole? So we will discuss what we discussed in the last class. I will take a short recap of 2 minutes. But before I start anything, let me introduce you. I'm Rahul Kaushik. I worked there in Bansa classes Kota since 2010 to 2020, continuous 10 years. And I was head of department there. And I mentored 2000 plus IITians there. And now I'm here on Unacademy, India's largest and fastest growing online platform. And I'm sharing my experience and knowledge with you guys. And I'm really enjoying it. And now, how you people can subscribe to Unacademy? Just go to App Store or Play Store, download Unacademy Learning app, install it. Once you install it, you will be directed to a page. On that page, click plus. Once you click on the plus, some courses will be populated. You have to check IIT JEE. You have to check IIT JEE. Once you check this box, just click on the get subscription. And once you click on the get subscription, you will be directed to these options. For 1 month, you will be charged 6,000 rupees per month. But 1 month is useless for you guys because I'm preparing you for 2022. I'm teaching as per 2022 syllabus curriculum. And now, if you choose this plan, and it would be best for you guys, you just have to pay 1,500 rupees. Right? And I'm telling you, 1,500 rupees per month. It translates to 50 rupees per day. And over and above, if you apply my code Rahul Chem, remember this code. If you apply this code, you are going to get a flat discount of 5,400 rupees. Right? So don't forget this code. If you apply this code, you are going to get the discount. My code is Rahul Chem. Right? So guys, let's crack it and start lecture number 2. So what we did in lecture 1, first I will discuss it. So let's see who are in the class. Hi Arshu, hi Pawan, hi Monica, hi Sandeep. Good afternoon everyone. Hope you people are doing good. Yes. Hi Krishna. You people are late. I am on time. Yes. So, are you guys ready? Oh, I missed Jack Sparrow, the on-time guy, Priyanka Ravichandran. Yes, hi Priyanka. Hi Captain. Captain, always on time. Okay. I think Priyanka, it's your first class. Or have you attended some other class also? Hi Sandeep. So you guys ready? Hi Manish. Yes. So in the previous class I told you what is mole, and I just told you, just like to measure mass we have fundamental unit kg, to measure time we have unit second. Okay, that's fine. To measure time we have unit second. Similarly, when we say amount of substance, it means to measure the amount of substance we have a unit mole. But when we are saying amount, that amount can be number, that amount can be mass, and that amount can be volume. So it can be anything, right? So I told you, if you calculate mole, you can calculate number of that substance, you can calculate mass of that substance and volume. In yesterday's class, we were doing calculation of mole, and we did mole calculation using number and using mass. Now it is left by using volume only. And I gave you some illustrations in which we converted. I gave you mass and you calculated numbers, and vice versa. I gave you number of atoms or molecules and you calculated their mass. right? So do you have do you guys have any problem? Hi solutionist, hi Sandeep. So Sandeep, I am taking class for 2022 batch 3 to 4 p.m. and for 2021 batch I am taking 1 p.m. to 2 p.m. Liquid solution is going on there and I'm teaching mole concept here. Good afternoon solutionist. Good name. Creative guy. You might have heard alchemist and now there is one more entry, solutionist. So if you do today, if we complete calculation of mole by volume, then I hope you guys are never going to stuck in mole calculation problem, right? I'll try my best. Okay, okay. So once you do the mole calculations, and I told you even in the previous class that I will start with 0 level and we will move up to advanced level. Even yesterday also, I just started like a 9th standard student can also learn. And then I increased the level of problem. We calculated number of electron, proton, neutron and everything. And now you are through it. So the same strategy we are going to use today. So now mole calculation using volume. Now what is that? So in case of for solids and liquids, we know density is equal to mass upon volume. So if volume of solid or liquid is given, then what we are going to do? Using density and volume we can calculate mass, and once we calculate mass then we will calculate number of mole. So not an issue. But for gases, yes, here comes the point. For gases, there are some interesting point about gases. The point are, suppose this is cap. I think you can see it. This is cap, right? I have some chlorine gas. Yes, I have some chlorine gas and it is here. See it? So once this chlorine is inside this cap, the volume of chlorine is equal to volume of cap. Now I have opened this cap. Now this volume, that chlorine gas has been escaped in throughout the room. And now what is the volume of chlorine? It is equal to volume of room. What I want to tell is that gases don't have their own volume. Their volume is equal to the volume of container in which they are kept. So if I'm taking a container and here I'm taking gases, right? Here I'm taking gases. So I can push this piston or pull this piston. So once I push it or pull it, what's going to happen? Its volume will change, and basically volume of gas will change. So volume will change and pressure of gas will also change. In gaseous state, we will discuss these things in detail, but right now I'm just telling you. So what we do? For gases we apply PV is equal to nRT, and we can calculate moles is equal to PV upon RT. Now what is N? Number of mole. P, pressure of gas. V, volume of gas. R, it is called gas constant. T, it is called temperature, and you always have to take this temperature in Kelvin. Yes, you always has to take this temperature in Kelvin. So are you guys ready with pen and pencil and copy, notes, everything, right? So now, because you people are new, you have just completed your 10th class, so I have to discuss these points a bit because you don't know much about these points, right? So what are these points? Let me discuss it. What are these points? So first of all, we will take pressure. First of all, we will take pressure. Listeners, don't worry, have some patience. I'm coming to all these points: pressure, volume, temperature, R. Don't worry. Mole, you know, so I'm not talking about mole. Yes. So let's take pressure. Actually, in gaseous state, the next topic I'm going to start is gaseous state. In gaseous state, I will tell you how we will measure pressure using barometer. So using barometer, when we measure pressure, then the pressure of atmospheric surrounding, it is taken as 1 atm, and in barometer we use mercury, so that pressure is measured in terms of mercury itself. So 1 atm will be equal to basically 76 centimeter of mercury, or we can call it 760 mm of mercury, or it is 760 torr. This is also one of the unit. In Pascal, in SI unit, it will be 1.01325 into 10 raised to the power 5 Pascal. Got my point? So actually there was some setup barometer, and in barometer we use mercury, and that mercury is filled like this, and it reaches up to this height, and basically this height comes out to be 76 centimeter. So we measure it in terms of 76 centimeter. I'm not going into details of that. Hi Triveni. Bent rule and Drago's rule as such directly they are not there, but they are just 5 to 10 minute concepts, so they don't take much time. So you can go through them. They will help you in giving some explanations. So this is 1 atm. So 1 atm is atm for atmosphere. There is one more unit, 1 bar. It is equal to 75 centimeter of mercury, or 750 mm of mercury, and it is 750 torr. It will be equal to this. So now you can relate 1 atm and 1 bar. 1 atm is equal to 1 bar is equal to, now divide it. So I will get 1 atm is equal to, or 1.0132. So atm is basically a bigger unit. So I hope you got it. Now I told you all these units. You must know the conversions. So let's do some elementary problem. Convert pressure in atm. First one is convert then in atm. Yes. Now using the above relations, just convert them. Hi Parmita. Convert them in atm. That's why I told you these units, so that you guys can convert units easily. You might have done all these things in physics. Right? So yes. Are you done with it? Sandeep, Parmita, Triveni, solutionist. Yes, anyone. So what will you do is 76 centimeter it says. So when you will convert in ATM, you will divide it by 76. right? But it will be 1.5 atm, and here you have 152. Yes, Somil, Ravi, Shiva, Reddy, it will be 2 atm. It will be, now here you have to divide it by this. It will be 30 atm. And what it will be? 0.5 atm. So I hope now you are comfortable in conversions, right? So this is all about pressure. So now you know about the pressure. Pressure is done. Now let's take another unit, volume. What is this volume? I told you gases don't have their own volume. The volume of container is basically called volume of gas. The volume of container is basically called volume of gas. So 1 ml is basically 1 centimeter cube, and 1 centimeter cube we also write it as 1 cc. First C for centimeter and second C for cube, right? So every one of you know 1 liter will be equal to 1000 ml or 1000 centimeter cube, right? You know it. Now the point is 1 meter, just convert them in centimeter cube. Convert it, and in liter. Yes, do it fast, everyone. I'm waiting for your reply. Okay, Sandeep, definitely I'll increase. So 1 meter cube will be equal to what? So basically 1 meter is equal to, yes, 1 meter cube, just cubing both side. So here I can write, now how many liters are there? How many liters are there? So 10 raised to the power 3 centimeter cube make 1 liter. So 10 raised to 6 centimeter cube will make, so it will be 1000 liter. It will be 1000 liter. So you can do conversions easily. Now there is one more point. What is 1 decimeter? Deci, milli means 10 raised to the power minus 3. Deci means 10 raised to the power minus 1 meter. So it is equal to 10 centimeter. 0.1 meter is equal to 10 centimeter. So 1 decimeter cube will be equal to, just cubing on both sides. So what is that? 1 liter. Why I am telling you? If somebody writes okay, I'll take a special class for this, but right now it is very difficult. Solutionist actually, unitary method start from 8th and 9th. So just unitary method. 1 chocolate in 10 rupees, 10 chocolate in 100 rupees. So now, if I write 2.5 decimeter cube, I can also write 2.5 liter. So instead of decimeter cube, I can directly write liter. Actually, 1 decimeter cube is equal to 1 liter. Right, you got it. Yes, tell me. So now you are done with the units, because many a time you will encounter like 5 decimeter cube and you need liter. Now what will you do? You need liters. So you would just write 5 liter. That's fine. Or you cut it right and write 5 liter. Got it? So now it is done. So now my volume is also done. Now let's take temperature first and then we will move to R. So what is this? Temperature T. So students, keep in mind, now for next 2 years till you take your JEE Main and JEE Advanced exam, always take temperature in Kelvin. Always take. You have to take temperature in Kelvin. And how to do that? It will be 273 plus T degree Celsius. And it will be Kelvin. Actually, it is exactly 273.15, but we ignore that because of calculation difficulties. So, just do it. Convert temperature in Kelvin. Do it fast. Very easy. It will be. It will be 0 Kelvin. So, yes, this is called absolute zero. This is called absolute zero. You got it? So now you are comfortable in temperature also. Although they are not important, but you should also know there are one more scale and how to do this conversion. I am telling you a simple formula for that, and that is very important because for Fahrenheit you people generally don't remember that this. So the formula is T degree. Suppose I am taking degree Celsius, so freezing point of water in degree Celsius is 0 degree and boiling point is 100 degree. So 100 minus 0. So it is basically, if you see here, this is boiling point minus freezing point, and here we have freezing point. Similarly, there is a Fahrenheit scale as well. In Fahrenheit scale, freezing point is 32 Fahrenheit and its boiling point of water there is 212. So now you can have Kelvin scale. So in Kelvin scale, 0 degree you will take. So it will be 273 upon 373 minus 273. Just remember it. Right? So if I say convert ~18 degree Celsius into Fahrenheit, just do it fast. Solve it. Yes, I'm waiting. So how will you convert degree Celsius into Fahrenheit scale? How? So you can do one thing. Just put 18 degree here. Right? And now it is done. You can write it like this way. And now this is done. You could have also done reverse. If I have given you something in Fahrenheit, you could have converted them into degree Celsius. Yes, solutionist, you are right. You people are so intelligent. You do problems so quickly. Yes, Somil, you are also right. So let's start. Values of R. Now everything is done. When we take PV is equal to nRT, so R will be PV upon NT. So now pressure, volume and T all are done. So fourth point, and that fourth point is values of R. Yes, someone was asking it. Very important. So keep in mind always, take temperature in Kelvin always. So temperature issue is resolved. You always have to take temperature in Kelvin, right? You always have to take temperature in Kelvin. So now, yes, solutionist, you are asking. So now the point is, how will I take values of R? So in this, I will take case 1. If pressure is in atm and volume is in liter, 80% problem will be on this proper unit. So you have to remember these units, not 80, actually 90% in gas state or in mole concept. So what you are going to do, what will be the units of R? If pressure is in atm, then it will be atm, liter, mole inverse, Kelvin inverse. And you have to take value of R 0.0821. Remember it. These are experimentally determined. Yes, are you guys writing it? Make proper notes of it. It will help you for next 2 years. Yes. Now case 2. If pressure is in bar, volume is in liter, then value of R would be 0.0831 bar liter. So 5 to 8% it will be used. So you have to remember these units. You have to remember values of R when pressure is in atm and volume is in liter, and value of R when pressure is in bar and volume is in liter. Right? I hope now you got the values. Let me take 2 more values. Right now we will not use them, but you should know. In SI units. So in SI unit, pressure will be Pascal and volume will be meter cube. So value of R will be 8.314 joule. This is basically, bar liter is basically joule, because pressure is Pascal, meter cube. So now it is joule, mole inverse, Kelvin inverse. Mole inverse, Kelvin inverse. So it is SI unit, and we will use it rarely. In thermodynamic, it will be used extensively, so you should know the value. Now CGS, case 4. In CGS, R will be 1.98 calorie, mole inverse, Kelvin inverse, and we generally take it as 2 calorie mole inverse, Kelvin inverse. I hope there is no other value other than these four. These four, out of four, these two we will use rarely. In thermodynamic, we will use them extensively. But now you have to remember these two at least. Yes, you have to remember them. I hope it is done now. Right? So let's do one thing. Just what is molar volume? In last class we did molar mass and I told you molar means of 1 mole. So what is molar volume? Tell me. What is molar volume? Volume of 1 mole. Like we said, molar mass. Mass of 1 mole. Molar of 1 mole. So molar volume is, it is volume of 1 mole of any substance. But here we people are dealing with gas, so I'm considering it as gas. Any other substance. So for gas, I will write PV is equal to nRT. Actually, this volume is of n mole, and if I take n1, then it will become volume of 1 mole, and I write m subscript. So I will get PVM is equal to RT. So this Vm is molar volume. When we put n is equal to 1, it becomes molar volume. Any doubt? Let me know. Right? So there are two conditions. One is normal temperature, and pressure. I call it as NTP. What is that? Normal temperature means you have to take it 273 Kelvin, and pressure means you have to take it 180. So now let me ask one question. Calculate molar volume at NTP. Actually, why do we need molar volume? In case of solids and liquids, suppose I am taking this pen, the volume of this pen is fixed. Volume of this pen is fixed. If I am taking this glass, volume of this glass is fixed, surface area is fixed. But in case of gas, volume is not fixed. How? Let me tell you. Suppose here I am taking this gas, right? Suppose this is 1 mole oxygen. So right now its volume is 5 liter. So now 5 liter is volume of 1 mole. So it is molar volume. But what you can do is you can push it or pull it. So if you push it or pull it, you can increase its volume. You can decrease its volume. In either case, it will be called molar volume. So it can have molar volume 50 liter. It can have molar volume 2 liter. More than 5, less than 5. So actually if molar volume will change, when you will push it or pull it, pressure will also change. So whenever we are talking about molar volume, I have to provide pressure as well because on changing pressure, volume of gas will change. On changing pressure, volume of gas will change. So now calculate the molar volume at NTP. So I am defining here pressure and temperature, and you know it. Just do it, everyone. Solve it. Yes, I am waiting for your answers. Do it. Yes. Sawmill 22.4 liter, correct. Anyone else? Yes, Sawmill, you have done it right. Yes. No one else? I'm getting no other replies. So I will simply write PVM is equal to RT. So VM is equal to RT by P. Now it says NTP. So at NTP, pressure will be 1 atm and temperature will be 273 Kelvin. So molar volume will be R. So if it is in atm and it is in Kelvin, so I will take it R 0.0821 and temperature in Kelvin, that is 273. Pressure will be 1. So it will be 22.4 liter. So this is volume of 1 mole at NTP. So any gas is taken, if any gas is taken at NTP, this will be the volume we are going to get. This is volume of 1 mole. And there is one more interesting point. If there is any gas, 1 mole of that gas will have this volume. It can be H2O2, N2, CO2, CH4, anything, irrespective of the gas. Right? If I ask you, calculate moles of gas at NTP, and all volume given are at NTP, and I am giving you 11.2 liter of H2, 44.8 liter of N2, all volumes are taken at NTP. Just do the calculation, calculate the moles. Yes. So simply using unitary method. And what unitary method says? 22.4 liter means 4 liter at NTP means 1 mole. 1 liter at NTP means, so V liter at NTP means, so this is basically the formula, but you can apply this formula only at NTP. It is not like you are applying it anywhere. So at NTP you are going to get 0.5 mole. Here you are going to get 2 mole. Here you are going to get 4 mole. It is 5.6. 1 by 4 mole. I hope you got it. Yes. Yes. Any doubt? 5.6. Got it? So this is the volume or molar volume at NTP. Now do one more calculation. Calculate. Okay, I just told you NTP. There is NTP. There is one more thing, STP. Standard temperature and pressure. STP. So what is that STP? Temperature you have to take 273 Kelvin and pressure you have to take 1 bar now. This is the difference. At NTP you have to take pressure 1 atm, right? So now do a problem on it. Calculate molar volume. Just do it quickly. You have all the values of R. Yes, do it. Yes. Yes, anyone. So how we are going to do it? Calculate molar volume at STP. Again, PVM is equal to RT. No, it's wrong. VM will be RT by P. So now you know at STP temperature is 273 Kelvin and volume of P is 1 bar. So value of R I have to take is this. So in this case I am going to get 22.7 liter. It is slightly higher than 22.4. Slightly higher. So STP and NTP are two different things. Most of the place they are taken as same. That is wrong. That is wrong. So now the volume, molar volume is this. Pallavi, there is no particular book that we can call best. You can practice better. It would be you just attend some lectures and solve some institute material and follow NCRT. Yes, there is no one book for whole chemistry. So now you know the formula. This is basically molar volume. So 22.7 liter at STP means 1 mole. So 1 liter will constitute mole and V liter will. I hope now we got another formula. V upon 22.7 and this volume we have to take in liter and it is at STP only. And that 22.41 was applicable for NTP only. For inorganic there is no book, just follow NCRT. Yes, I hope you have done it. So now we have calculated all the formulas for mole calculation we have done. RC Mukherjee is better. But RC Mukherjee have only some topics problem that are useful. Mole, gas state you can do from RCM, stoichiometry part. Yes. So now we have done mole calculation and there are many formulas now. N upon Na, W upon M, and there is one more, PV upon RT. There is one 22.4 in liter, 22.7. We can calculate mole using these formulas. We can calculate mole, right? Do you have any doubt? No doubts. Actually, this formula is applied. This formula is applied at NTP. This is applied at STP, and this you can apply anywhere. And these three formulas are for gas only, and these are for solid, liquid, gas, for anything, for everywhere. Because we use PV is equal to nRT only for gases. Only for gases. So let's solve a problem. Calculate number of moles of gas taken at 2 atm and 546 Kelvin in 10-liter vessel. Yes, do it. It would be better if you all guys remember these things, that this is equal to 22.4. It's important because it will come recurrently. There would be recurrence. Yes. Yes, just do it. Let's see who solves it. Here I have not mentioned NTP or STP. I have given you the pressure and temperature. So you have to apply PV is equal to nRT. Yes, solve it. You just have to apply PV is equal to nRT. Do it. Yes, do it. No answer? We are given 2 atm, volume 10 liter, N will be, yes, so pressure will be 2 and volume is 10 into this 546. I can write it as, so this whole term is 22.4. So this is your answer. I just told you that, just remember this thing. It will come out to be 22.4. I hope you got it. Got it? Yes. Okay. Let's take one more problem. Eighteen ml. Solve it. 90% will do it wrong. Just solve it. Yes. No answers. I am waiting for your answers, guys. Yes. I am waiting for your answers. So what you are going to do is PV is equal to nRT. So this pressure is 1, volume is 18 ml, you will convert it, then mole But this is wrong. But this is wrong. Why? It is water, and this formula is applicable only for gases, so it cannot be applied for liquid and solids. One thing is clear now. It cannot be applied for liquids and solids. So if water is a liquid, then we know density of water is 1 gram per ml. So mass will come 18 gram. So mole of water will be 1 mole. You got it? If it is 1 mole, problem is done. So that's the error which you guys commit. And there are two more terms, like if I write 0.2 gram molecule of H2S, then what does it mean? Yes, Somil, you are right. If I write 0.2 gram molecule of H2O, what does it mean? Actually, gram molecule, it is not mass. When it is write like gram molecule or gram atom, underline it and write it as 0.2 mole of H2O. It is same. Always keep in mind. Always keep this thing in mind. If I am writing 0.5 gram molecule of CO2, just after gram, if molecule or atom appears, underline it and write it as mole. It will be 0.5 mole CO2. Right? So if I write 0.2 gram atom of hydrogen, then what does it mean? Again, underline this gram atom. So gram atom or gram molecule is basically mole. It is mole of atoms, it is mole of molecules. So I will take it as 0.2 mole of hydrogen atom. Right? Yes, Somil. If I write 0.3 gram molecule of hydrogen, so it doesn't mean 0.3 gram, it means 0.3 mole of hydrogen molecule means H2. So it is another name of mole, 1 mole. So let's see how many names are there for mole. So 1 mole is basically 1 gram atom, 1 gram molecule. It is Avogadro's number Na. It is gram atomic mass, gram molecular mass, molar mass, molar volume, and there is one more term, gram ion. So these are all names of 1 mole. Just note it down. These are all names of 1 mole. If I'm writing 0.1 gram ion of CO32 minus, it means 0.1 mole of CO32 minus. Gram ion, gram atom, gram molecule, that is basically mole. Right? That is basically mole. Yes. Yes. So I hope you got it. Got it? So now let's do some practice over here. Solve it. Question: calculate mass of O2 gas present in 5-liter vessel at 38 centimeter of Hg and 273 Kelvin. Yes, solve it. Solve it. Wait quickly. I'm just making you comfortable in units. Otherwise, you would not be able to solve mole problems. You have to know how to convert units. So just solve these problems. Yes, tell me. Yes. So what will I do? You need mass of O2. Now the volume of gas is 5 liter. Pressure is 0.5 atm and temperature is 273 Kelvin. So now I'm going to use PV is equal to nRT. Moles will be PV upon RT. So pressure is 0.5, volume is 5 and temperature is 273. So now you know it will be 2.5 and it is, you have to remember it. So this is mole, so W by 32. So weight you will get this is your answer. Yes, you got it. Yes, Somil, you are right. Yes. Yes. So let's move ahead. So there is one more thing, atomicity. What is that atomicity? Like if I'm writing O2, O3, P4. So if I ask you atomicity, what is that? What is O2? Oxygen. How many atoms of oxygen are taken here? 2. So atomicity will be 2. Here atomicity will be 3. Here atomicity will be 4. So number of atoms making a particular molecule is called atomicity. Why I am asking it? Because this particular expression is applied for gases. And here if I write in W by M RT, now I'm saying it is for oxygen gas. Then what should be the value of molar mass here? Is it 16 or 32? Tell me, is it 16 or 32? What is that? Because oxygen gas, when I'm saying it is O2, atomicity is 2. You have to take its molecular mass, not atomic mass, in which state it exists. It is 32. Yes, Somil, you are right. It is 32. So let's take one problem. So in case of P4, you have to take 4 into 31. So let's take one problem over this. How such problems are asked. So I'm increasing the level. Calculate atomicity of gas if 48 gram of it at 0 degree Celsius and 44.8 decimeter cube vessel exerts a pressure of 0.5 atm and it is given atomic mass of gas is 16. So you have to find out atomicity. Okay, the one. Now solve it. Do it. Yes, I'm waiting for your reply. It is very interesting problem and important conceptual problem. Okay, Manish. I'll change this background. I'll ask technical team. If this is so, then I will use some black. Actually, I don't like. So I will use some background that do not pinch your eyes. You are given 48 gram of gas. You are given temperature. You are given volume. Right? You are given pressure. Now you just have to calculate atomicity. Means that molecule, how many atoms are making that molecule? Yes, tell me. Okay, Krishna. Okay, don't worry. I'll ask technical team. Bear with me for the time. Meanwhile, Captain Jack 7. So I hope you are getting molar mass. You have to take molar mass of that gas. That gas can be P4O3. So it consists of 3 atoms. So its atomicity will be 3. So how will you find molar mass? It will be 3 into 16. How will you find molar mass? It will be 4 into 31. So basically atomicity into atomic mass. So now weight is 48 gram. Temperature is 273 Kelvin. Volume is and pressure is. So now I will use PV is equal to nRT W by mRT. So pressure I know 0.5, volume I know, W I know 48. I don't know molar mass, right? So it will be 0.0821 into 273. So I will get here 48 upon m into what is this? 22.4. And what is this? 22.4. So molar mass will be 48. So I just told you what is molar mass? It is atomicity into atomic mass. So atomic mass of gas is 16, molar mass is 48, so atomicity will be 3. I hope you got this answer. I hope you got it. Yes, guys. Here, if I take this P4, here atomicity is 4 and you are multiplying it by atomic mass to get molecular mass of this. So gas will be in molecular state. Yes, the one you are right. Yes. Any doubt? Please tell me. Captain Jack. Okay. So let's start another problem. Which of the following will have maximum number of atoms if equal mass of each is taken. CH4, oxygen, SO2. Yes, just do it. Just do it. Any answers? Which of the following will have maximum number of atoms if equal mass of each is taken? How will you solve? See, whenever such type of problem is asked, instead of taking x, take some easy value, because whatever value you take, answer should be same. So here I know the molar mass of it is 64, it is 32, it is 16. I am taking 64 gram. I am taking 64 gram of each instead of taking x. Then problem become easy. That's what I am telling you, how to do problems faster without making any guesswork. So divide it by 32. You are going to get 4 mole, 2 mole and 1 mole. So it has 4 mole and I am asking maximum number of atom. So it has 4 mole of CH4 and one molecule of CH4 has 5 atoms, 4 hydrogen in this. So atoms will be 4 into 5 mole. It has 2 atoms, so 2 into 2, 1 into 3 mole. So maximum number of atom will be of CH4. Yes, Somil, the one, you are right. Captain, you are wrong. This time you are wrong. Yes. So let's solve one more problem. Do it. Ethanol is the substance commonly called alcohol, and the density of liquid alcohol is 0.8 gram per ml. No, it is wrong. It's wrong. Just use the approach I told you. Now solve it. Now ethanol is the substance commonly called alcohol. The density of liquid alcohol is 0.8 gram per ml. And if 1.2 mole of ethanol, okay, let me tell you formula for ethanol, C2H5OH. No, Priyanka, it's wrong. CH4. Yes. Now do it. Yes. Yes. No answers. I'm waiting for your answers. Tomil says B. And what other says? What other says? Yes, I'm waiting for your answers as well. You know the density of ethanol is 0.8 gram per ml and 1.2 mole of ethanol are given. So what is that? What is that? See, ethanol. What will be the molar mass of ethanol? So moles are 1.2. So weight will be this. Now what is asked? What is the volume? So density is weight upon volume. So volume will be weight upon density. So weight is and density is 0.8, 2 and 3, 23, 69 ml. C is the answer. So B was wrong. A was also wrong. Answer will be C. Answer will be C. Are you getting it? Yes, tell me. Normally you did it wrong. It was simple problem. Right? So before starting quiz, let me take a bit difficult problem. Okay. Note it down. What volume of liquid A2O3 has same number of atoms as there are atoms in BO2 liquid having volume 20 ml, given density of A2O3 is 1.5 gram per ml, density of AO2 BO2 is this, molar mass, atomic mass of A is 50, B is 60, O is 60. So it is very good problem. Just solve it. It is not an easy problem, purely logical. Let's see who solves it. Yes. Do it. Do it, guys, quickly. Yes. Any answers? Any answers? 9 ml. Correct. Somil said 9 ml and it's correct. How we are going to solve it? Yes, tell me how we are going to solve it. Just see, same number of atoms as there are atoms in BO2. So here we have BO2 and A2O3. Number of atoms are same. So one molecule of A2O3 will have 5 atoms. So number of atoms in A2O3 are equal to number of atoms in BO2. So now what will I do? Yes, you are also right, the one. So the number of atom will be, here we will have 5 into moles of A2O3 and here I will have 3 into moles of BO2. I have just done this. Now 5 into weight of A2O3 upon molar mass, 3 into weight of BO2 upon molar mass. So molar mass of A2O3, and what is the molar mass of A2O3? A have 50. So A2O3 will have molar mass 50 into 200 and 48, 148. And BO2 have 60 into 32, 92. 148, 92. Weight of A2O3. I hope it's clear now. Now how to find weight? Now you are given density of A3. So it will be upon volume of A2O3. It will be so now you are given 20 ml of BO2. So weight of BO2 will be 20 into 0.7. It will be 592 and density is 1.5 into volume of A2O3. Once you solve it, you are going to get volume of A2O3 9 ml. So it was very interesting problem. Very interesting. I hope you got it. Yes. So do you have any doubts? Yes, tell me. Any doubts? I hope it is done now. Done. So this is all about mole calculation we have done. And now it's time for RK quiz. Revise your knowledge quiz. And the first question on your screen is this. Just solve it. Do it fast. Yes, I'm waiting. Yes. So what should be the value? Tell me. What should be the value? Mass of two atoms is this. Then atomic mass of element. Any answers? Mass of two atom is given, then atomic mass of an element is, take Na, 10 raised to the power, actually it is 23 per mole. Yes. Now do it. Yes, 10 raised to the power 23. Somil, you are right. Now tell me. So the concept is, suppose I say atomic mass of carbon, you write 12 AMU, and what is mass of 1 mole? You write 12 gram. So either you calculate mass of 1 mole in gram or you calculate mass of one atom in AMU. That will give you atomic mass. Relative atomic mass, I can say 12. So basically this is mass of two atoms. So two atoms have mass. One atom will have, and any atom will have 12 gram. So it is this. I got no replies from you guys. And it was a simple problem. It was really a simple problem. Yes. Yes, tell me. So now the next problem on your screen, solve it. Solve it quickly. Yes. No answers. The number of carbon atom present in a signature written by carbon pencil weighs this. So it is basically given weight. So you need number. So mole will be N upon Na and W upon M. So weight is, and molar mass is, what is the molar mass? 12. Now Na you know. So you will get N. This Bombay. Is it Bombay or Delhi? Yes, you have done the wrong thing, Somil. Even you know how to solve, still you are getting -1 mark. So such error should not be there. Such error should not be there. When you don't know anything and you are doing something wrong, then that is fine. But when you know each and everything and you are solving it wrong, you are getting -1 for the correct thing you know. That is the worst mistake. If you people keep on repeating it, then you are never going to get a good rank in IIT. So let's move to the next point. Question number 3. Now solve it. Solve it. Number of moles of this compound. The whole compound is given in its pure sample. If the sample contains 4 mole of oxygen atoms. Yes, how will you solve it? It is revise your knowledge. RK quiz means revise your knowledge. and it is also my name, Rahul Kaushik's quiz. So you can take it as yes. Now solve it, solutionist. The one, yes, yes. Now what's that? If you write, no, I'm getting no answers. So let's see KH C2O4.95. If I take one molecule of this, the number of oxygen atom will be 4 plus 4 into 0.95. So if these number of moles of oxygen are there, then I will say 1 mole of it is having these number of molecules. If sample contain 4 mole of oxygen, so I can write if sample contain itne mole of oxygen means 1 mole of dot H2C2O4 and 1 means 1 upon and 4 means yes. I hope you got the answer, and it is this. Got it? So I think now your mole concept is getting stronger and stronger. Yes. Now solve it. Fourth. Yes. Now solve this. 4 education says it's C. Let's see. And what all others are saying. How many moles of magnesium phosphate contains 0.25 mole of oxygen atom? So if I take, I can say 8 mole of oxygen atom are present in 1 mole of Mg3PO4 का whole twice. So 1 mole of O will be present in 1 upon 8 and 0.25 mole of O will be present in, so it will be 1 by 32. So what will be the answer now? It will be, I think, C. Yes, for education, you were right. You were right. Yes. Yes, did you get it? Did you guys get it? Tell me if you have any doubts. Okay. Now there is one more problem. That is last problem. Now solve it. You have a sample of this and it contains 64 gram oxygen. Then mass of copper in the same sample will be, take mass of copper as 63. Simple question it is. Yes. Yes, tell me. RK quiz means revise your knowledge, and RK is also my name, Rahul Kaushik. So you can take it as this. Revise your knowledge. Whatever you have learned today, you are going to uh, apply that concept here. Yes. Yes, Ravish, you are right. Okay, now solve it. You have a problem here. Solve it. Okay, after this, I will take a problem from solutionist. No worries. Just solve it. Then I will take your problem. It says copper sulfate dot 5H2O, and this sample contains 64 gram oxygen. Now if I take 1 mole of this, 1 mole of it contains 9 mole of oxygen. 5 and 4. Now if I'm saying 9, if 9 mole of oxygen are there, then 1 mole of copper is there, and 9 mole means 9 into 16 gram. So I can also say if 9 into 16 gram of oxygen is there, then 1 mole means 63 gram of copper will be there. And if 1 gram of oxygen is there, then it will be. And if I'm taking 64 gram of oxygen, simply unitary method. So it is 4, 7. So you are going to get 24 gram of copper. 28. I hope you got it. Yes, Triveni. So now let's take a problem, and this problem has been asked by solutionist. So let's take it and solve it. What is that problem? So now your calculation of mole is done. Tomorrow we will solve some problems over it. Not on the mole exactly, on the application part of it, and then we will proceed ahead. So the question is, a gaseous mixture contains, just note it down, everyone, oxygen and nitrogen in 1:4 ratio by mass. The ratio of number of molecules is, just solve it, everyone, just solve it. Very good problem. So let's take this problem as well. Tomorrow advanced level problems will be done definitely, because today I was just telling you how to calculate mole, and tomorrow definitely advanced level problem will be there. Even today we had some very tough problems. Yes, mole calculation actually generally direct problem from mole calculation never comes in IIT JEE Advanced, but you must know how to calculate mole. So how will you solve? You have a gaseous mixture of oxygen and nitrogen. So if it is 4 gram, it is, sorry, it is 1 gram, it is 4 gram. Now you need the ratio of molecule. So molecule is equal to mole. So ratio of moles will be same as ratio of molecules, because Na will be cancelled. So you just calculate mole ratio. Just calculate mole ratio. It will be, so 7:32. Done? Yes. Yes. So let me tell you what we are going to do tomorrow. Tomorrow I will tell you. Tomorrow I will tell you what is vapor density. And have you ever thought I told you AZ, this is mass number, and mass number is sum of neutron plus proton, and I told you it should be integer. Then why 35.5 is written over here? It should be integer only. So what is this 35.5? What is this 35.5? Is it mass number? Mass number can only be integer. So tomorrow I am going to discuss all these conceptual points. Why do we take this as fraction? What is specific gravity? What is relative density? And then finally, average atomic mass. Yes, we are going to take all these things and then we will solve some problems, some very good problems over that. Right? So tomorrow's class is going to be really very interesting. As you guys have seen today, the quiz was really very good, and tomorrow I am going to take that class. So guys, before we wind up this session, if you really like this lecture, then please share and like it as much as possible. Like it and click on the bell icon so that you guys can get latest notifications of my lectures as well as lectures of other teachers on this particular channel. So how you people can subscribe to Unacademy? You can just move to your Play Store or App Store and then download Unacademy Learning app. Once you download it, click on the plus. On clicking plus, you will be directed to a page where IIT JEE and NEET, all these courses will be there. Just click on the IIT JEE page. Once you click on it, then you have to click on get subscription. So once you click on get subscription, you are going to get it. For 1 month you have to shell out 6,000 rupees. But we are going for 2022. So you just have to pay 1,500 rupees per month if you want to get it. And over and above, if you apply my code RahulChem, then you are going to get flat 10% discount. And I'm telling you, once you are part of Unacademy, you are just going to get not just my lectures or videos, you are going to get videos, content, lectures of all senior faculties present in your particular stream you have chosen. Suppose you have taken IIT JEE, then it will be there. So tomorrow's class is going to be really very interesting, and now tomorrow we will learn how to apply mole concept. The application part will be done tomorrow, right? So guys, get ready for tomorrow's class, and that's it for now. We'll meet you tomorrow in the next class, and take care.